you for joining. So yeah, you've seen a little bit of a glimpse today with Michael and the demo of the workspace, and we wanted to take it a little bit further in this session and go about the GraphConnect attendee graph. So we all sat down there with Emil and hearing the presentations, and I guess everybody was wondering, okay, who is the guy next to me? Who is this lady 2 rows in front of me? Who are they? We all know, okay, they come here because graphs is what they are interested about, but do we know more? Not really. Could we know more about the other people that are attending GraphConnect, and what is it that is an overlap or a similarity between the users? And yeah, we thought about this, and we loaded the data, looked at the data, and with that, we explored a little bit today, and want to find out a few more data points, a few more similarities during this session. So what we did is we have the data anonymized, of course. So Michael already told about this. So the names will be IKEA products. The company names will be just randomized and different, of course. So it's not 100% clear who these are. Graph use case we kept, of course, and all the rest we kept. Job, country, and then when you did register via the event app, you can add favorite food, favorite sports, I think also, favorite type of vacation. We added those as well, and we look at that. So how does it go? It's fairly simple. It's basically a 1, 2, 3 exercise. So as the demo goes, we will do some modeling, look at it, draw a virtual whiteboard up, and type the data there. Then second step, obviously import the data, use the data importer you saw earlier, and you'll see now in a second how quickly it goes, and how easy it is to have an Aura instance up, go into the data importer, load CSVs, put the data in there, and directly drive the data into a Neo4j Aura instance. And from there, you don't have to go into browser anymore. You could basically just jump into Bloom, and that's basically step 3, and explore the data. So that means it's virtually a low-code exercise. The data model will look something like this. So basically attendees, use cases, where people are coming from, the state and country. We have obviously companies, we have industries, all these things. So we'll explore this a little bit. And then we have questions we can ask the data and see if we can find out some interesting things. So first, easiest step kind of is, who are you, right? I mean, where are you coming from? What's your favorite vacation type? What's your graph use case? So that's like step 1, and that's interesting, but not really graphy in a way. But we can go further down, and we can go deeper in it, and we can really drive insights, and we can see. And I won't read all of these, but communities of attendees based on the similarities. I mean, that's an interesting step. Who has a colleague from another country around? I think that's interesting. Or what are industries mostly located in? So where's an overlap here, or which use cases are common? But I guess I'll stop talking, and Michael will do some exploration, or we see what it looks like and how it works, and find some insights in the attendee graph.
Yeah, thank you, Alex. So actually, I wanted to mention these kind of live streams of exploring data sets is something that Alex and I do every Monday. So if you're interested in like all kinds of stuff, from gas pipelines in Europe to NFTs to Kickstarter data set, Eurovision Song Contest. So we just every Monday we pick a data set and model it, input it into Aura, and explore it and have some fun with it. So there's also actually an YouTube playlist for this. So if you're interested in that, we have all the videos of the recordings and also write-ups for those as well. So that's quite nice. Last week we actually did the Aura agenda, not the attendees, but the agenda, pulling in the agenda with all the topics and the speakers and so on. But there's a lot of stuff to be had, so I didn't want to forget to talk about this. So you saw our AuraDB free instance that I just created in the keynote. It's running in Iowa, so I hope it lasts through the session. Otherwise, we just recreate a new one. And so usually we create just a blank instance. There's no data in there, and usually these data sizes that Aura Free offers are good enough for initial data exploration. So that's really nice. And so with the Open Workspace button now, we get to Workspace. So I didn't show that in the demo because what you have to do is basically you have to log in still. So that's something where I just make this a little bit bigger. Can you read this okay from the back? Cool. So what you would say, I want to connect Workspace to my Neo4j instance. You can also connect it to non-Aura instances in principle as well. So that's my Aura instance and then my password. I hope I didn't mistype this one. So it's connected now. And now all the three things are available. So you've seen that I imported the attendees already. So let me just pull this in again. So these are the CSVs that we've already mapped. So the users, their roles, country, state, expertise, and use cases, basically by adding nodes and dragging out relationships and mapping things from the CSV file to each node. What's important, we want to select an ID for each node so that we can efficiently import the data and also connect things, right? So if you don't have in our data like source and target ID, then it's hard to create relationships as such. Data import works well with normalized and denormalized files, or even if you have files where there are duplicate entries of the same things multiple times, then it can work through this, and you can have a single file which has 10 different dimensions, basically denormalized, flattened out, and then Data Importer merges it together again when it's importing data. So what's also really cool is because how we import the data in Data Importer is idempotent, so you can run it time and again, and it will not add more data, but it will just update things. So what we can do now is actually we can add our extra file. So Alex mentioned that there is the favorite data as well. So the favorite data is actually, I had this open, that's in Sheets. Sheets, Google.com. The GraphConnect attendees. So we have the ones that I showed you before. Just let me put this on 150% or so. So the ones that I showed you before, and then there's the one that's called here secretly Sheet 1. So where we pulled out favorite sport and favorite vacation out of the attendee app that you could select, because that's more normalized data than the free form like US sports teams, which I have no clue about anyway. So so we're gonna add these to our imported data. So what you basically do is you add this extra file, which is not mapped, so it's not green yet here, and now I can basically drag out nodes. So for instance, I say something like sport. I select the favorites file, map the sport entry to this node. I rename this from favorite sport into just sport. So you can also change data types here, which is quite nice. So if you have, for instance, numeric values or Boolean values, so we'll also add date time support and other things. So that's also quite nice to map data types immediately at import. And then we just call this favorite sport, and then use the mapping from the file again. We map from participant ID to sport. And then we can do the same with vacation real quick. The favorites, add from, oops, sorry. So you can also add properties that are not in the file and then map them manually, but I usually use the map from file, file directly. So our favorite vacation, and then we select this as ID, and then we just call the relationship favorite vacation. So if you want to, you can also flip out the direction. So if you click on this button here, then it flips the direction. And I map the stuff again in here. Oh, sorry, from participant ID to favorite vacation. And so then I have mapped all my data. I can run the input again, so it will add this additional information to the graph. I could have also just kept the attendee and this vacation on sports and removed all the other stuff as well. Then it would have just added the new data to the graph, right? So that's really nice for incrementally adding more data sources to your graph as such. Cool, now we have it in a graph. So I already showed you the schema visualization, which has now 2 new fields, which is sport and vacation up here. And we can query this from that perspective. We can also explore in Bloom. So let's see if this works now. Let me refresh this. Should be in there. Actually, I think we need to add sport and vacation as new categories. And then we can, for instance, say, okay, from attendee, let's say via sport to attendee, what is like a similarity graph here, right? So I say basically, what are typical clusters of interests on a sports site, right? And we see that Bloom is thinking, there we go. So that's kind of the clusters that we see. So we have basically, what is this? American football, tennis, hockey, and so on. So these are how people are clustering as such. What we can now also do is kind of to say, we pick all these people in our graph, and we can just select them, and then say we want to expand the favorite vacation relationship as well. So that's kind of the double overlap between sports on one side and vacation on the other. So we could, if you had GDS running as well, we could now start kind of creating clusters where this kind of overlap becomes apparent. Some of the questions that we can answer really quickly is what Alex had in the beginning, like this here, where we just get a bunch of attendees and their attributes, or let's start with one. So who is someone? This person has not added so much information. So let's pick a bunch of them, like 20 or so. So these are like different people coming from different states, having different sports and interests, and kind of that's their ego network, and you see already some overlaps. What's the interesting question is what Alex said before is, for instance, people coming from a certain industry, are there overlaps with use cases? So that's something that we can express as a graph pattern, where we say we start at the industry, and then we start at the attendee, who comes from an industry, then another attendee comes from the same industry. Yes. Actually, I want to do it the other way around. So actually what I wanted to say is we have an attendee who comes from an industry, and then this attendee has also a use case. And now what we're looking at is actually what's the overlap between the two. So we say the industry, the use case, and how frequently did they co-occur, basically, right? So this pair of industry and use case, which ones are the top co-occurring ones, right? And so we sort the result by count descending and return the top 10 or so. And so you see that software seems to be really prevalent here as an industry, being everywhere. So if we were to exclude the industry not in software, not. So then it becomes interesting, right? So then, of course, from life sciences industry, so use cases are life sciences, but there are also like lots of knowledge graph stuff in life sciences, right? There's financial services, fraud detection is also something that's an obvious one, right? So you see kind of these first insights coming from just people registering to your conference, looking at the bigger patterns, you kind of see these kind of things. So what we can do in the next steps is actually materializing the similarity relationship between people as a relationship in a graph, right? So where we say, okay, when people share attributes, so use case, expertise, industry, where they come from, and so on, this kind of constitutes a similarity. So the more attributes they share, the more similar they are. And this is where the attendee pair comes in. So we have one attendee which has a certain attribute, and the second attendee which also has this attribute. So we get these two attendees and count how often they overlap. So if you have 5 things in common, you're more similar than if you have 2 things in common. And we only want to see the ones where the count is, let's say, greater than 2. And then we create a new relationship between the two, similar A2. One trick, if you've not seen this before, for relationships, on merge you can leave off the arrow tip, so it basically will create an undirected relationship. So similar is undirected, so you don't need to express in direction. And then we just set the weight of the relationship as our count. And if you do this, it should create a bunch of relationships. Let's see. So it created 18,000 relationships in our graph, right? So it's kind of take the cross product between all the people, and all the people that have more than 2 relationships between them are similar. So if you now go back to Bloom, refresh our perspective so that the new relationship gets added, clear out this scene here, and then just say, what is our attendee to attendee network in terms of similarity? Then we can run this, and it will give us probably quite a hairball of data. Let's see. But what's really cool in Bloom is that there are these filters that we can use to reduce the density of that network. So somehow the Bloom thing is not as nice as... Okay, we can do this in the browser as well, right? So we can just say, give me my attendees with a similar relationship. Similar relationship, and I just return the ones, this path, where the count, where s.count is greater than 5, or yeah, so that we have a not as dense graph. Let's see what happens. Similar. Can anyone see the mistake, the spelling mistake, or is oh, sorry. Yes, it's called weight. See, that's why I need to have you pay attention. Good one. So let's take the 5. Otherwise, it's getting too many relationships back. Okay, and now it should actually show us something. Come on. Okay, so this is still quite a dense graph, as you can see. So it has, what was it, like 5,000 relationships? So I guess I need to increase this weight filter a little bit. Let's say, oh, because we added the additional sports and vacation. So now you can actually see this kind of similarity network appearing. And now you could basically say, okay, can I filter or can I identify clusters and communities in this one? So if I had GDS running on this instance, then I could actually just go and run clustering algorithms on top of this network. But this was really just meant to show you how easy it is to get from source data into the graph and then creating a similarity network from that, even without GDS. So, and oh, now Bloom came back as well. And now what we can do in Bloom is actually there's these cool filters. So we can say on our similar relationship, we want to filter the weight property. You have this histogram here. And then, for instance, if you say, okay, I want to go for 8, apply the filter. And then we can, for instance, say, apply the filter. And then we can say dismiss filtered elements. So that leaves us with only a subset of the graph in here that I can now look at, right? So this is a really dense cluster. So it could be that it's actually the Neo4j people, because they also all share a company as well, and many share like the same location. And then the other poor people have not so many similarities. So for instance, if I pick this person and expand similarity, then they're also connecting to the main cluster here as well, right? So, but that's just meant to show you how easy it is to get from 0 to insights as such. And I think, when did we start? 6 past, right? Or 8 past or so. Okay. You have 20 minutes or so for the lightning talk. I think these were the things that we wanted to look at in terms of questions. Oh no, we had also where our industry is mostly located. That's also a good one that we can do. So if you find our industry, where's our industry? Here's our industry. And we want to say in which state and country they are. So we can say, is there an overlap between industry and country, actually? Country. And so we can do something similar for that. So we have a lot of US things as well. But you see also here, for instance, Japan is coming up, interestingly, right? So hello to everyone from Japan. Really, really nice to see that. We can also say where, if we filter out the US to see who's coming from elsewhere, where country is not US. Then it becomes interesting, right? So I think country, California, there's some data problem, right?
Canada.
Oh, Canada, sorry. Canada. Sorry. Israel, more Canada. So there's more overlap from here. Yeah, it could be. I mean, we could also actually, because this is Cypher, it's easy to say collect distinct s.state as states. So you also see what is coming in here. So for instance, for Canada, there's Ontario and British Columbia as well, right? And Norway has also regions like Oslo, and I'm not sure what the other one is.
Is there a way to get more insights on those who put software as an industry? Because that's kind of very general.
Yeah, so unfortunately there's no breakdown in the industry. But what we could do is basically for those people, we could also add these attendees that are in this industry. For instance, if we say, we also want to say the use case as well. So then we could say collect distinct use case. So these would also say the use cases. So for instance, software here has master data management. Let me just remove the states really quick. Master data management, AI, graph data science, more AI. It's only, because I limited it to 10, sorry. If you limit it to 200 or so, then we should have some more. So software, recommendation engine,
Supply chain.
Yeah, supply chain and so on. So it would be good if you had like software plus something as such. So, and with that, I think we are at time. If you have more questions, feel free to
Visit us at Dev Zone.
find us in the Dev Zone. Exactly, that's where the ARC is. So that's not St. Louis, but it's the Dev Zone. And so we're hanging out there, and